Okay, here we've got a heat pump. Okay, refrigerant 134A, and basically what I know is out of the evaporator into the compressor, I have 2.4 bar saturated vapor. Okay, then coming out of the condenser, which is state 3, is saturated liquid at 8 bar. So again, this is the compressor, this is the condenser, this is the expansion valve, and then 4 to 1 is the evaporator. Okay? So, what I need to do for each one of these is to go through and set my states. So, obviously states 1 and state 3, I can look up. I know those states. 1 to 2 is the compressor, right? It's an ideal compressor. Therefore, I'm going to look up S1, and I know that's going to equal S2. Then using P2 and S2, I can look up H2, setting state 2. State 4 is really easy because it's the expansion valve, so 3 equals 4. So once I have state 3, I know state 4. So that's how I'll go ahead and set my states. So let's go ahead and get started. So 134A, we'll start at 2.4 bar and saturated vapor. So H is 244.09 and S is 0.9222. Okay? So again, that is 244.09 and 0.9222. Of course, that also equals S2. So we've got that. Now we'll go and find, let's just do state 2 right now, okay? So this will be compressed, and it'll be a vapor. So 8 kilograms. S is 0.9222. So you can see I'm in between the 0.90 and the 0.93, between essentially 31.33 Celsius and 40 Celsius. So my H value is going to be right around 270. What is it exactly? 268.97. That's my H value here. Okay. Now I go back to saturation, saturated liquid at 8 bar, and then because of the expansion valve, 4 is the same thing. So I go back to 8 bar, saturated liquid, and that H value is 93.42, which again is going to be the same as state 4 because of the expansion valve. So that is 93.42, 93.42. Okay. So now, okay, I want to know the power input to the compressor. What I know is that it's putting out 15 kilowatts of heat into the building. That is essentially Q out in the condenser, right? That's the energy being lost from my fluid into the space. So I'm going to use that condenser Q out to actually figure out the mass flow, which is the next thing I want to do. And again, that Q out occurs 2 to 3. So that'll be H2 minus H3. So again, that equals 15 kilowatts as given in the problem statement. So knowing Q out 2 to 3, knowing H2 and H3, I can then calculate my mass flow to be 0.08544. And that is kilograms per second. Now that I have my mass flow, I can find the power input to the compressor, which of course is 1 to 2. So the work of the compressor is that mass flow times H2 minus H1. Okay? Again, now I know my mass flow, I know my states, so I can find that power input, and that power input is actually 2.126 kilowatts. Now that I have the power input, I can easily find the coefficient of performance, which for a heat pump is, again, Q out over the work of the compressor. Okay, so that's 15 over 2.12, and that actually gives me a coefficient of performance of 7.055. Okay, so again, as with anything, set your states, find your mass flow, calculate what you want. These problems are pretty much all the same.